of October as well. So based on that, I hope most of you guys will make it, and our TCS selections will be around, at least 15 from both divisions. So hopefully, let us see if we catch up that 20 or 30 count this year. So with this, uh, academics is also, as I told you, academics is also going to be there. T part 2 examination was cancelled, but this may not happen during B part 1 examination. We are bound to appear for B part 1 examination, although it will be conducted in an online mode, but at least we should be able to be attempt these multiple choice questions in a reasonably good manner. The way B Part 2 examination was recently conducted for our previous batch, on the same line, almost 50 questions will be there for your university examinations in an online mode, and MDS being your one of the theory subject, you will have to face 50 MCQs. 50 MCQs for that online MDS examination. Although you are going to appear for the examination from your home, from your comfort zones, but we need to spare a considerable amount of time on the preparation of all the subjects. So now, until 10th of November, we will finish out with our syllabus, and after Diwali, we will have a couple of revisions of this particular chapters. So with this, let us focus on section 2 that we have started on 2nd or 3rd of October, if I'm not wrong. Section 2 we had initiated, and the name of the section 2 chapter is object-based databases. Now, you have shifted from procedure-oriented programming language to object-oriented programming language. Why that change has occurred? The change has occurred because procedural-oriented programming languages were insufficient, were incapable of handling complex things, complex real-world things. So there was a considerable shift from procedural-oriented programming languages to object-oriented programming languages. In the same manner, object-based databases were invented, and object-based databases were assumed to serve the purpose of handling complex data types. Relational model can handle only tabular form of a data, only payroll management system, only basic things relational models used to do, tabular sort of a thing. But object-based databases can handle these variety of data types, complex data types, and how this thing is being done. That is the main motive behind this particular chapter, called as object-based databases. So first point we're going to look into is overview. Then we will be looking after complex data types, the term that I'm trying to mention over here. Then we will have structured types and inheritance in SQL. Then we will have table inheritance. Then we will have this little bit complex data types in the form of arrays and multisets. Then we will have this object identity and reference types in SQL. And finally, we will differentiate between object oriented database management systems versus object relational database management systems. So I hope you all are listening. There are only 7 points in this particular chapter, unlike our first chapter where almost 12 to 15 points were there. And we will be dealing with these 7 points in our upcoming discussions. So we will start with overview, then we will have complex data types, structured types and inheritance in SQL will be our third point. Then we will look into table inheritance. Now inheritance is a concept that you are well aware, parent-child relationship, grandparent, parent and child relationship. That way we will deal with this particular point. Then arrays and multisets types in SQL we will look after, and object identity and reference types in SQL, along with object-oriented database management systems versus object relational database management systems. These are the points. These are the 7 points that we will be interested to deal with. I would be, I would be very happy to say that on 2nd of October, when we had conducted our earlier lecture, almost 3 points we have covered. So we will have a glimpses of these 3 points, and then we will, accelerate ourselves into this further points. Now, to begin with, let us understand the importance of earlier models, and let us understand the significance of this object-based databases. So traditionally, database applications were consisting of simple tasks such as banking and payroll management. So only data processing related tasks used to be there. And these tasks were handling simple data types that are well suited for relational data model. So simple tasks and simple types was the bottom line of earlier database applications. So if you are able to remember simple data types and simple tasks, but if we are into complex data types, then complex tasks are bound to be there, and existing or relational data model was insufficient to deal with all these aspects. So as and when the database systems were applied to wider range of applications such as computer-aided design, geographical information systems, limitations were imposed by relational model emerged as an obstacle. So relational models were insufficient. That will be the point that I would like to reiterate again. Relational model was insufficient because it used to handle simple types and simple tasks. But as and when computer systems grew up, applications grew up, so computer aided design and geographical information systems and the operation of the likes of these were very much complicated, and relational model was insufficient to deal with these advanced applications. So the solution that was suggested was introduction of object based databases which allow one to deal with complex data types. So the first and the foremost obstacle faced by programmers using relational data model was limited type system. Very few simpler data types were there, very limited types were there. These were supported by relational model. Then complex application domains require correspondingly complex data types. And what sort of complex data types are required? So we say nested record structures, record within a record, then multi-valued attributes. Multi-valued attribute, you can simply say you people are also having multiple phone numbers, multiple email IDs, personal email ID, college email ID, personal phone number, public phone number. So multi-valued attributes are the attributes where there can be more than one value. Aadhaar card cannot be having under category of multi-valued attributes. You will have unique Aadhaar ID. You will have unique PAN number. You will have unique passport number. You will have unique voter ID number. So these cannot be the attributes or of multi-valued attributes category. But yes, you can have multiple bank accounts. You can have multiple phone numbers. You can have multiple degrees. You can have multiple vehicles. तुमच्याकडे 2-3 बाइक्स आहेत किंवा तुमच्या नावावर 1-2 कार्स आहेत, शिवाय बाइक्स पण आहेत 1-2. तर याचा अर्थ काय की मल्टी व्हॅल्यू ऍट्रिब्यूट्स असतील तर ते अर्लियर रिलेशनल मॉडेल टाईपने हँडल होऊ शकत नव्हते. म्हणून हे कॉम्प्लेक्स डेटा टाइप्स आणि ऑब्जेक्ट बेस्ड डेटाबेसेस वर कन्सिडर्ड. And one more thing that was incapable by relational model was inheritance. So inheritance was the concept or the entity that was unable to be handled by these relational data model. Now all these complex things are basically supported by traditional programming languages. Such features are in fact supported by ER and extended ER notations, but had to be translated to simpler SQL data types. Now let us get up to the next slide which focuses on object relational data model. Now, this object relational data model extends the relational data model by providing a richer type system, including complex types and object orientations. Relational query languages, in particular SQL, need to be correspondingly extended to deal with richer type system. So are you understanding? Basic data types and richer data types. Richer means multi-valued attributes will come up there, inheritance will come up there, and the advanced concepts will come up there. So object relational data model not only performs its own functionalities, but it also extends relational data model by providing a richer type, including complex data types and object orientation. So relational query languages, in particular structured query language, need to be correspondingly extended to deal with a richer type system. Such extensions attempt to preserve the relational foundations, in particular the declarative access to the data, while also extending the modeling power. So these extensions are very useful, very helpful, because not only they are preserving relational foundations, but also they are extending the modeling power. So with these both advantages of giving declarative access to data as well as extending the modeling power, this object relational data model becomes very much considerable and powerful. Now, next is object relational database systems. That is, database systems that are based on object relational model provide a convenient migration path for users of relational databases who wish to use object-oriented features. Now, the second obstacle, पहला obstacle कुठला होता? Data type related. Next obstacle is difficulty in accessing the database data from programs returning programming languages such as C++ or Java. So data types, complex data types was a problem, as well as second problem or the second obstacle is the difficulty in accessing the database data from programs written in programming languages such as CPP or Java. Now, there is a contradiction over here, and we will be looking into it like this. Merely extending the type system supported by the database was insufficient to solve this problem completely. The differences, what sort of differences? The differences between type system of a database and type system of a programming language make the data storage and retrieval more complicated, and it needs to be minimized. Having to express database access using language such as SQL that is different from programming language again makes the job of the programmer harder. So it is desirable for many applications to have programming language constructs or extensions that permit direct access to data in the database without having to go through intermediate language such as SQL. I hope you're understanding. It is always desirable for many applications to have a programming language constructs or programming language extensions that permit direct access to data without intervention of intermediate languages such as SQL. So primarily in this chapter, we will explain motivation for development of complex data types. After that, we will study object relational database systems. And what are these object relational database systems? Specifically using features that were introduced in 1999 and 2003, SQL 1999 and SQL 2003. Please note that most database products support only a subset of SQL features described in here for supported features. The syntax often differs slightly from the standard. This is the result of commercial systems introducing object relational features to the market before standards were finalized. Refer to the user manual of database system that we might be using and what sort of features that it is supporting. Then Finally, we will be addressing the issue of supporting persistence for the data, that is native type system of an object-oriented programming language. Two approaches are used in practice. First is build an object-oriented database system, that is database system that natively supports an object-oriented type system and allows direct access to data from object-oriented programming language using native type system of the language. Hope you are clear with the idea. First approach is build an object-oriented database. Build an object-oriented database, that is a database system that natively supports an object-oriented type system and allows direct access to data from object-oriented programming language using native type system of the language. Automatic convert data from the native type system of the programming language to relational representation and vice versa. Data conversion is specified using object relational mapping. Now we provide a brief introduction of both these approaches. Finally, we outline the situations in which the object relational approach is much better than object oriented approach, and the relative vice versa relationship, and finally mention criteria for choosing the correct option or correct alternative between them. Now let us come to our interesting point of this particular chapter called as complex data types. So you are aware why do we look into this particular slide? Because database applications were not only related to payroll management systems, student management systems, payroll management system, student management system, book management system. So the database applications were also intended for geographical information systems, computer aided design systems, and for that sake, relational models were insufficient. Relational models were not, reasonably good. So this advancement had to be done, and so we entered into object-based databases. And the primary point under consideration over here is complex data types. So let's understand. Traditional database applications have conceptually simple and simpler data types. The basic data items are records that are fairly small and whose fields are atomic. Atomic means these are indivisible. So that is, they are not further structured, and first a normal form holds over there. Further, they are only a few record types. आपलं उदाहरणार्थ आपलं नाव लक्षात घ्या. आपलं नाव असेल तर तिथे ना फर्स्ट नेम हा एक त्यातला परत सबपार्ट येईल. फादर्स नेम और मिडल नेम दॅट विल बी अगेन अ सबपार्ट, अँड आवर सरनेम विल बी अगेन सबपार्ट ऑफ इट. सो atomic means indivisible. सो फर्स्ट नेम इतकाच आपण जर फर्स्ट नेम इतकाच प्रेझेंटेशन कोणी स्टार्ट केलंय? Stop presenting. Who is presenting? मोबाईल वरून प्रेझेंटेशन कोणीतरी स्टार्ट केलंय. स्टॉप प्रेझेंटिंग. ममता जांगीर, तुम्ही बहुतेक प्रेझेंटेशन स्टार्ट केले, बंद करा. Other people can simply pin my presentation so that even if other person is presenting, you will not be getting disturbed. Mamta Jangid, stop presenting. Mamta Jangid, stop presenting. मीटिंग लीव्ह करून परत या वाटल्यास. ममता जांगीद, मीटिंग लीव्ह करून परत या. तुम्हाला लक्षात येत नाहीये. Other people can pin my presentation. Other people can pin my presentation so that there will not be any hindrance. There will not be any problem. Other people can simply pin my presentation. So let us focus on this particular fact. Atomicity means what? Indivisibility. है ना? अणू अणू किंवा काय म्हणू आपण ऍटम. ऍटम पूर्वी कन्सिडर केला जायचा की इनडिव्हिजिबल पार्ट आहे, सगळ्यात बेसिक पार्ट आहे. पण नंतरच्या फिजिक्स मधल्या संशोधनामध्ये असं दिसून आलंच की इलेक्ट्रॉन्स आर देअर, प्रोटॉन्स आर देअर, न्यूट्रॉन्स आर देअर, आणि अजून काय काय शोध लागतातच आहे. त्यात पॉझिट्रॉन आहे म्हणे किंवा आणखीन काय काय अजून गोष्टी आहेत. सो ऍटम पहिल्यांदा जो इनडिव्हिजिबल कन्सिडर केला जायचा, तशा पद्धतीने इथलं लॉजिक लक्षात घ्या. In basic data items were fairly simple and whose fields were atomic, and atomic means they are not further structured and first normal form particularly holds there. Further there are only few record types. So लक्षात घ्या काय म्हणायचं आपल्याला, बेसिक डेटा टाइप्स किंवा बेसिक रिलेशनल मॉडेल मधले फीचर्स, atomicity and few record types. Now in recent years demand has grown for ways to deal with more complex data types. Consider for example addresses. Even if you consider simple address, then there will be a field called as street address. है ना, आपल्या पत्त्यामध्ये असतं लोकॅलिटी, विलेज, जे काय असेल ते आपला चौक असेल, स्ट्रीट ऍड्रेस असेल, सोसायटी असेल, गल्ली असेल, हे सगळे परत इंटरनल फील्ड येतातच. सो वाई इवन इफ वी कन्सिडर सिम्पल एक्झाम्पल ऑफ ऍड्रेस, आपण अगदी काय जिओग्राफिकल इन्फॉर्मेशन सिस्टीम पण डोक्यात घेत नाहीये. जिओग्राफिकल इन्फॉर्मेशन सिस्टीम मध्ये तर कितीतरी कॉम्प्लेक्स गोष्टी आहेत. तिथे एंटायर अर्थचे वेगवेगळे नाही का वेगवेगळ्या टाइमचे सगळे स्नॅपशॉट राहतात आणि त्याचं अनालिसिस चाललेलं असतं. सो तिथल्या तर गोष्टी कॉम्प्लेक्स आहेच आहेत, बट त्यातल्या त्यात कॉम्प्लेक्स ऍड्रेस आपण कन्सिडर केला तर ऍड्रेस मध्ये सुद्धा ही सगळी फील्ड्स येत आहेत आणि ह्या सगळ्या गोष्टी कॉम्प्लिकेटेड होतात. So relational model becomes insufficient. So we say while an entire address could be viewed as an atomic data item of type string, this view would hide the details such as its street address, city, state, postal code, which could be of interest to the queries. On the other hand, if an address were represented by breaking it into components, and what can be the components of an address? Street address, city, state, and postal code. Writing queries would be more complicated since they would have to mention each and every field. I hope you are understanding. So the best alternative is to allow structured data type. This structured data type allows type address with subparts street address, city, state, and postal code. As another example, consider a multi-valued attributes from the ER model. Such attributes are natural, for example, representing phone number, because people may have more than one phone numbers. The alternative of normalization by creating new relation is expensive and artificial for this particular example. Now, with complex type systems, we can represent ER model concepts such as composite attributes, multi-valued attributes, generalization, and specialization in a direct manner without a complex translation to relational model. We define 1NF. 1NF, you're aware, first normal form, which requires that all attributes have atomic domains. Recall that a domain is atomic if and only if it is considered of having indivisible units. The assumption of 1NF is natural one in the database application examples we have considered. However, not all the applications are best model for 1NF relations. For example, rather than viewing a database as a set of records, users of certain applications view it as a set of objects or entities. These objects may require several records for their representation. Now, a simple, easy to use interface requires one-to-one correspondence between users' intuitive notion of an object and the database system's notion of data item. So there has to be a scenario mapping, there has to be a proper association between which two entities. These two entities are users notion of an object as well as database systems notion of a data item. त्या दोघांमध्ये प्रॉपर अंडरस्टँडिंग असायला हवं. So let us consider, for example, a library application, and suppose we wish to store the following information about each book. So information can be book title, list of authors, publisher, and set of keywords in that particular book. So we can see that if we define a relation for preceding information, several domains will be non-atomic. Non-atomic म्हणजे लक्षात येते, atomic म्हणजे indivisible, non-atomic म्हणजे divisible. त्याचे तुकडे होऊ शकतात. जसं की ऑथर एखाद्या बुकला एकच ऑथर नसेल. there can be multiple authors. आपल्या आत्ताचे डेटाबेसचे जे बुक रेकमेंडेड आहे त्या बुकला सुद्धा जवळपास 3 ऑथर आहेत. कोर्थ, सिल्वर शाज and Sudarshan are the 3 authors for the book, and that's why we can say that it is an attribute which is non-atomic. Non-atomic म्हणजे divisible, atomic म्हणजे indivisible. Authors, पहिला आपण मुद्दा घेतला समजा. Authors, a book may have a list of authors which we can represent as an array. Nevertheless, we may want to find all books of which Jones was one of the authors. Thus, we are interested in the subpart of the domain element, authors. Now, let's understand what is meant by this second entity, keywords. If we store a set of keywords for a book, we expect to be able to retrieve all books whose keywords include one or more specific keywords. Thus, we waive the domain of the set of keywords as non-atomic. Next is publisher. Unlike keyword and author, publisher does not have a set value domain. However, we may waive publisher as consisting of the subfields name and branch. This view makes domain of publisher as well in a non-atomic form. Following figure is an example that is showing relation books in the following manner in a non-1NF form. So title, you are understanding compilers. Title, second title is networks. For compilers, authors are Smith and Jones. Publisher is McGraw-Hill, New York. And keyword is parsing and analysis. For second title, author can be Jones and Frick. Publisher in the form of name and branch is Oxford, London. And keyword set is internet web. So this is divisible sort of a relation, म्हणजे non-1NF sort of a relation called as books. For simplicity, we assume that the title of the book uniquely identifies the book. We can then represent the same information using following schema, where the primary key attributes are underlined. So first is author's title, author position. Keywords are title and keyword. Books are title and book madle keyword. And books for relation is title, publisher name, and publication branch. The above schema satisfies 4NF, fourth normal form, that is shown on the next slide. So if you are able to understand and if you are able to relate this particular table on this slide with our 4NF, then you will get this particular author table, keywords table, and books for table. So author table, what it says, title, it is repeated because we had to go for this particular 4NF version of the relation books. So compilers will be mentioned twice, networks will be mentioned twice as a requirement of 4NF. Then keywords relation will be again transformed like this. And finally, the books for relation will be like this: compilers, publisher name McGraw Hill and publication branch New York, while networks, publisher name Oxford, publication branch London. So this is how authors, keywords, and books relation can be transformed from this earlier version to this 4NF version. Although our example although our example book database can be adequately expressed without using nested relations, the use of nested relation leads to easier to understand model. The typical user or programmer of an information retrieval system thinks of database in terms of books having set of authors as the non-1NF design models. The 4NF design requires queries to join multiple relations. Multiple relations will be associated there, whereas the non-1NF design makes many types of queries easier. On the other hand, it may be able to use first normal form representation in other situations. For example, consider the text relation. You know, it is again a different relation called as text, and this text relationship says in our university example, the relationship is many to many between student and section. We could conceivably store a set of sections with each student or a set of student with each section, or we can go for both. If we store both, we would have a redundancy. Redundancy, you are aware about this term. Redundancy is repetition. The relationship of a particular student to particular section would be stored multiple times or twice in this particular scenario. The ability to use complex data types such as sets and arrays can be useful in many applications but should be used with proper care. Now, let us get into our third point called as structured types and inheritance in SQL. Before SQL 1999, the SQL type system consisted of fairly simple set of predefined types. Only predefined types were there. Those were again very simpler. In SQL 1999, there were additions of extensive type system to SQL, allowing structured types and type inheritance. So there might be an MCQ on this particular point. In SQL 1999, the extensive type system was added, and it allowed structured types and type inheritance as well. So let us understand what is meant by structured types. Structured types allow composite attributes of ER designs to be represented directly. For an example, we can define the following structured type to represent a composite attribute name with component attribute first name and last name. So understand this example. Create type of type name as first name varchar of 20, last name varchar of 20, and there will be a final keyword. Final meaning there will not be further divisibility of the entity. Final meaning it will not be further divisible. Non-final means it can be divisible. Similarly, the following structured type can be used to represent a composite attribute address. Create type address as address bagata, street varchar of 20, city varchar of 20, zip code varchar of 9. Like that, this address can be again structured, and a keyword not final is appended over here. Not final means it can be further divisible. Final means it cannot be further divisible. लक्षात घ्या हे दोन फरक. Such types are called as user defined types in SQL. The final and not final specifications are related to subtyping. We can now use these types to create a composite attributes in a relation by simply declaring an attribute to be one of these types. For example, we could create a table person as follows. I hope you all are listening महत्वाच्या गोष्टी चालू आहेत, थोडंसं लक्ष असू दे. जरी एमसीक्यू टाईपची एक्झाम असेल तरी पण आपल्याला थोडा त्यातला अवेअरनेस तरी असावा. लक्ष द्या. डोंट टेक एव्हरीथिंग कॅज्युअली. Cooperate and get benefited. Now, this table person, how it is defined? Create table person, name of type name, address of structured type address, name of structured type name, आणि डेट वाला टाइप तर त्याचा प्रीडिफाईंडच आहे, बेसिक टाइप. सो डेट ऑफ बर्थ ऑफ टाइप डेट. Now, the components of composite attribute can be accessed using a dot notation, as we are aware of it. For instance, name dot first name returns the first name. An access to attribute name would return a value to the structure type name. We can also create table whose rows are of a user defined type. For example, we could define a type person type and create the table person as follows. So now understand how this person type is getting defined. Create type person type as name of name, address of user defined data type or structured type address, date of birth of type date, not final meaning it can be divided. This person type can be further divided, and we have to create a table person of person type. We have to create a table person of person type. Now, an alternative way of defining composite attributes in SQL is to use unnamed row type. For instance, the relation representing person information could have been created using row types as follows. So, create table person R. Here, name of type row, first name of varchar 20, last name of varchar 20, address, unnamed row type, street, city, zip code, and date of birth of type date, predefined type date. This definition is equivalent to the preceding table information, except that the attributes name and address have unnamed types. Attributes name and address have unnamed types, and the rows of the table also have an unnamed type. The following query illustrates how to access component attributes of a composite attribute. The query finds the last name and the city of each person. So, query दिली इथं, select name dot last name and address dot city from the relation person. A structured type can have methods defined on it. We declare methods as a part of type definition of a structured type. सो इथे आपल्याला मेथड स्ट्रक्चर टाइप मध्ये मेथड पण देता येतात. ही एक आपली ऍडिशनल ऍडव्हान्टेज आहे जी की रिलेशनल मॉडेल मध्ये पॉसिबल नव्हती. सो वी से क्रिएट टाइप पर्सन टाइप ऍज नेम ऑफ टाइप नेम, address of type address, date of birth of predefined type date. Not final is a subtyping method ensuring divisibility. Now the method is coming up here. Method age on date. Which method we are preferring over here? Age on date. समजा आजच्या डेटला, let's say 29th of October 2020. What is my age? It requires in many a times in different applications, what is the exact age of a person. So this method called as age on date can also be appended inside a definition, and it is actually intended to return interval year. So this way we can create the method body separately. The method body is again defined at the bottom of the slide. Create instance method age on date. It returns an interval year for a person type, and how it is to be done: begin return on date minus self dot date of birth, and achhi tarikh minus date of birth. And this is how this age on date method can be defined. Note that the for clause indicates which type this method is for, while the keyword instance indicates that this method executes an instance of a person type. Are you able to understand? The variable self refers to the person instance on which method is invoked. The body of the method can contain procedural statements. Body of the method is intended to consider or contain procedural statements. Methods can update the attributes of the instance on which they are executed. Methods can also be invoked on instances of type. If we had created a table person type, we could invoke the method age on date as illustrated below to find the age of a particular person. So simply go for this particular query. How it is to be done? Select name dot last name, age on date, and it will be having an attribute of current date from person. Now, in SQL 1999, constructor functions are used to create values of structured types. A function with the same name as structured type is constructor function for the structured type. For an example, we could declare a constructor for the type name like this. Now you have understood, you have studied the constructor in your object-oriented programming. You can relate with the impact of constructor over there and impact of constructor over here with this particular example. Create function name, first name, last name, returns a name, begin self, set self dot first name is equal to first name, set self dot last name is equal to last name, and we will end this particular clause. We can then use new name John and Smith to create a value of type name. We can construct a row value by listing its attributes within parentheses. For instance, if we declare an attribute name as row type with components first name and last name, we can construct this value for it, such as Ted and Cod, without using a constructor. So this is the benefit of using constructor. Now we have to make one conclusion, and conclusion is that by default, every structured type has a constructor. By default, every structured type has a constructor with no arguments, which sets the attributes to their default values. Any other constructors have to be created explicitly. There can be more than one constructor for the same structure type. Although they have same name, they must be distinguishable by number of arguments and types of their arguments. The following statement illustrates how we can create new tuple in person relation. We assume that constructor has been defined for address, just like constructor we defined for name. So let us understand insert into person values, and which values we are to insert. New name John and Smith, new address 20th Main Street, New York 11001, and date is like 22nd August 1960. So that way this can be easily done. यातला दुसरा मुद्दा आपल्याला बघायचा होता या पॉइंट मधला, and that point is type inheritance. Type inheritance हा तर तुम्ही शिकलेले आहातच आहेत ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग मध्ये. इथं आपल्याला या टाइपनी फक्त पाहायचं आहे ऑब्जेक्ट बेस्ड डेटाबेसेसच्या फॉर्म मध्ये. सो टाइप इनहेरिटन्स, लेट्स अंडरस्टँड. Suppose that we have following type definitions for people. Create type person. How we are creating the type? With name and address. Name varchar of 20, address varchar of 20. Now we may want to store extra information in the database about people who are students and about people who are teachers. So are you understanding? Extra information about people who are students and people who are teachers. Since students and teachers are also people, we can use inheritance to define the student and teacher types in SQL. Now create type student under person, degree and department. So BTech degree or BE degree, and your department can be CSE. Now create type teacher under the person, salary integer, salary whatever may be the case, 50,000, 70,000, 40,000 as per applicable, and department. department can be inside this teacher definition. Both student and teacher inherit the attributes of person. Personचे attribute माहिती आहेत, name and address. So both student and teacher are inheriting the attributes of teacher, name and address. Student and teacher are said to be subtypes of person, and person is a subtype of a student as well as teacher. Methods of structured type are inherited by its subtypes, just as attributes are. However, a subtype can redefine an effect of a method by declaring the method again while overriding the method in place of method in the method declaration. The SQL standard requires an extra field at the end of the type definition whose value is either final or not final. The keyword final says that subtypes may not be created from the given type, while not final says that subtypes may be created. Subtypes may be created. Now suppose that we want to store information about teaching assistants who are simultaneously students as well as teachers, perhaps even different departments. टीचिंग असिस्टंट लक्षात येते, आपल्या इथे कधी कधी एमई चे विद्यार्थी असतात. एमई चे विद्यार्थी, त्या एमई च्या विद्यार्थ्यांना ऑल्दो दे आर स्टुडंट्स, त्यांना टीचिंगची काही कामं दिली जातात. सो त्यांना आपल्याला म्हणता येईल टीचिंग असिस्टंट. स्टुडंट म्हणजे तुम्ही सगळे लोक बीई मध्ये शिकणारे, टीचर म्हणजे समजा आम्ही लोक, आणि टीचिंग असिस्टंट म्हणजे आपले एमई चे विद्यार्थी की ज्यांना स्टुडंट म्हणून पण रोल प्ले करायचा आहे, ऍज वेल एज काही ठिकाणी प्रॅक्टिकल्स वगैरे घेण्यासाठी किंवा आणखीन काही थिअरी लेक्चर्स घेण्यासाठी टीचरचा पण रोल प्ले करायचा. सो एमई चे विद्यार्थी म्हणजे आपले टीचिंग असिस्टंट. वी कॅन डू दिस if the type system supports multiple inheritance where the type is declared as a subtype of multiple types. Note that SQL standard does not support multiple inheritance, although future versions of SQL standard may support it. So we discuss the concept. For example, if our type system supports multiple inheritance, we can define a type for teaching assistant as follows. Teaching assistants are type, है ना? They are teacher as well as student. So create type teaching assistant under student as well as under teacher, because teaching assistant is not only a student but also it is a teacher entity. Teaching assistant inherits all the attributes of the student as well as teacher. There is a problem, however, since the attributes name, address, department are present in student as well as in teacher. The attributes name and address are actually inherited from common source. Grandparent कुठला? Person. Teaching assistant चे parents कोण झाले? Student and teacher. Student and teacher चे parent कोण झाला? Person. तर person आपल्या सध्याच्या एंटिटीचा टीचिंग असिस्टंटचा ग्रँड पेरेंट झाला. So the attributes name and address are actually inherited from the common source person. So there is no conflict caused by inheriting them from student as well as teacher. However, the attribute department is defined separately in student and teacher. In fact, a teaching assistant may be a student of one department and he can be a teacher in another department. To avoid conflict of interest between the two occurrences of department, we can rename them by using an as clause as in definition of the type teaching assistant. So as clause वापरतात confusion remove करायसाठी. Create type teaching assistant under student with department as student department and teacher with department as teacher department. I hope you are clear with the idea behind using this as clause. In SQL, as in most other languages, the value of structured type must have exactly most specific type. That is, each value must be associated with one specific type called its most specific type when it is created. By means of inheritance, it is also associated with each of the supertypes of the most specific type. For example, suppose that an entity has type person as well as type student. Then most specific type of the entity is student since student is subtype of a person. However, an entity cannot have a type student as well as type teacher unless it has a type such as teaching assistant, that is a subtype of teacher as well as of student, which is not possible in SQL since multiple inheritance is not supported by SQL. Now let's catch up with our fourth point, table inheritance. Now how this particular table inheritance is understood, let us catch up with few slides. Subtables in SQL correspond to ER notion of specialization and generalization, as we are aware. For instance, suppose we define people table as follows. Create table named people of type person, as a grandparent. We can then define table students and teachers as subtables of people as follows. So how this student and teacher is getting created of people, now we are understanding with this definition. Create table students of student under people, create table teachers of type teacher under people. Now the type of subtables student and teacher in the above example are subtypes of the type parent table person in above example. As a result, every attribute present in the table people is also present in subtables student and teachers. Further, when we declare students and teachers as subtables of the people, every tuple present in the students or teacher becomes implicitly present in the people. Thus, if a query uses the table people, it will find not only tuples directly inserted into the table, but also tuples inserted into its subtables, namely students and teachers. However, only those attributes that are present in people can be accessed by the query. SQL is allowing to find tuples that are in people but not in its subtables by using only people in place of people in query. So this only clause is getting used. पूर्वी आपण रिसेंटली कुठला पाहिला as clause, आता पाहतोय आपण only clause. So the only keyword can also be used in delete as well as update statements. Without the only keyword, a delete statement on a super table such as also deletes tuples that were originally inserted in the subtables, such as students. For example, we will consider a statement delete from people where P. This statement would delete all tuples of the table people as well as its subtable students and teachers that are basically satisfying the predicate P. If the only keyword is added to the above statement, tuples that were inserted in subtables are never affected even if they satisfy the where clause conditions. Subsequent queries on the super table would continue to find these tuples. Conceptually, multiple inheritance is possible with tables just as it is possible with types. For example, we can create a table of type teaching assistant. Now, this teaching assistant, how it is created? Create table teaching assistant of teaching assistant type under दोघांच्या parentshipच्या under आहे student parentship as well as teacher parentship, because teaching assistant is a student as well as a teacher. Now, as a result of the declaration, every tuple present in teaching assistant table is also implicitly present in teachers and in the students table. And also, in turn, it is available in the people table. People is of type person. Person is grandparent. We note that multiple inheritance of tables is not supported by SQL. Multiple inheritance is not supported by SQL. There are some consistency constraints for subtables. Before we state the constraints, we need a definition. We say that tuples in subtables are parent table, corresponding if they have the same values of all inherited attributes. This corresponding tuples basically represent the same entity. The consistency constraints or consistency requirements for subtable are each tuple of the supertable can correspond to at most one tuple in each of its immediate subtables. So it has to correspond to at most one table, one tuple. Second consistency constraint is SQL has an additional constraint that all tuples corresponding to each other must be derived from one tuple inserted into one table. For example, without the first condition, we could have two tuples in students or teachers that correspond to the same person. The second condition rules out a tuple in people corresponding to both tuple in students and a tuple in teachers unless all these tuples are implicitly present, because tuple was inserted in table teaching assistant, which is a subtable of both teachers and students. Since SQL is not supporting multiple inheritance, the second condition actually actually prevents a person from being both teacher and a student. Even if multiple inheritance were supported, the same problem would definitely arise if subtable teaching assistant were absent. Obviously, it would be useful to model a situation where a person can be a teacher and a student, even if a common subtable teaching assistant is not present. Thus, we can conclude that it can be very useful to remove the second consistency constraint. Doing so would definitely allow us an object to have multiple types without requiring it to have most specific type. Example is, suppose we again have type person with subtypes as student and teacher. Person म्हणजे कळतंय grandparent, student आणि teacher म्हणजे त्याचे first generation children, and corresponding table people with subtables teacher and students. So we can then have a tuple in teachers and tuple in students corresponding to the same tuple in the people. There is no need to have teaching assistant that is subtype of both student and teacher. We need to create a type teaching assistant unless we wish to store extra attributes or redefine methods in a manner specific to people who are both students and teachers. Now, we note that SQL unfortunately prohibits such a situation because of consistency constraint number 2 that is specified recently. Since SQL also does not support multiple inheritance, we cannot use inheritance to model a situation where person can be both a student as well as teacher. So this aspect cannot be easily satisfied with SQL because it is not allowing multiple inheritance. So as a result, SQL subtables cannot be used to represent overlapping specializations from the ER model. We can of course create separate tables to represent the overlapping specializations as well as generalizations without using inheritance. The process was described earlier in earlier discussions. Now, for above example, we would create tables such as people, student, teachers with students and teachers table containing the primary key attribute of a person and other specific to student and teacher respectively. The people table would contain information about all persons because it is a grandparent, including students and teachers. We would then have to add appropriate referential integrity constraints to ensure that students and teachers are also represented in the people table. In other words, we can create our own improved implementation of subtable mechanism using existing features of SQL with some extra effort in defining the table as well as some extra effort at query time to specify joins to access required attributes. We note that SQL defines a particular privilege called as under, which is required in order to create subtype or subtable under another type or table. So do remember this particular aspect. Under is a privilege. Under is a special keyword which is required in order to create subtype or subtable under another type or table. The motivation for this particular privilege or keyword is similar to that of reference privilege. Now we have to conclude by saying that SQL defines a privilege called under, which is required in order to create subtype or subtable under another type or table. The motivation for this privilege is similar to that of reference. With this, our 4 points are over. Now let's catch up with our 5th point under this chapter, and that is called as arrays and multisets in SQL. So why do we learn these particular aspects? Because our relational data model cannot handle this type of complex things such as arrays and multisets. So we have to understand, we have to study array and multiset types in SQL. So SQL basically supports two collection types. These are called as collection types. And these collection types are arrays and multisets. Array types were included in 1999, while multiset was added in 2003. There can be an MCQ on this. Arrays are added in 1999 version, while multisets are added in 2003 version. Now we must recall that multiset is nothing but unordered collection. Multiset is nothing but unordered collection, where an element can occur multiple number of times. Multisets are like sets, except that set allows each element to occur at the max once. Set मध्ये एकदा element mention होऊ शकतो. Multiset मध्ये multiple times an element can be mentioned. Suppose that we wish to record information about the books, including a set of keywords for each book. Suppose also that we wish to store the information of names of authors of a book as an array. Unlike elements in multiset, the element of an array are ordered. Array चे element order असतात. So we can distinguish the first author from the second author and so on, like that. The following example illustrates how these array and multisets valued attributes can be defined in SQL. So look at this slide carefully. Create type publisher as, what are the two attributes are concerned? Name and branch. Create type book as title, author array, publication date, publisher, of type publisher, and keyword set. एखाद्या book मधला keyword set. आणि या सगळ्या एंटिटीचा आपल्याला बुक तयार करायचा आहे किंवा बुक टेबल बनवायचा आहे. क्रिएट टेबल बुक्स ऑफ टाइप book. The first statement defines a type called as publisher with two components as name and branch. The second statement defines a structured type book that contains a title, author array, which is an array of up to 10 author names, a publication date, a publisher, of type publisher, and multi-set of keywords. Multi-set लक्षात आला? Multi-set of keywords. Finally, a table books containing tuples of type book is created. Note that we used an array instead of a multi-set to store the names of all authors, since the ordering of author generally has some significance, whereas we believe that ordering of keywords associated with the book is not significant. लक्षात येते? ऑथरच्या वेळेस आपण ऑर्डर्ड array घेतला, बट कीवर्डच्या वेळेस मल्टीसेट घेतला, कारण मल्टीसेट मध्ये ऑर्डरिंगची गरज नाही. अनऑर्डर्ड असेल तरी चालतं, अनऑर्गनाइज्ड असेल तरी चालतं, मल्टिपल टाइम जरी एखादा कीवर्ड असला तरी हरकत नाही. बट ऑथर नेमच्या बाबतीत मात्र पहिल्या ऑथरला पहिल्यांदा क्रेडिट, second author second credit, third author has to be given third credit, fourth author has to be given fourth credit. So accordingly, whenever the ordering is required, array is used. Whenever ordering is not significant, then multiset is used. In general, multi-valued attributes from an ER schema can be mapped to multi-set valued attributes in SQL. If ordering is important, SQL always can be used instead of multisets. Creating and accessing collection values. Now understand how these values are created and accessed. Now array of values can be created in SQL 1999 in the following manner. Array Silber Shah's Core Thani Sudarshan. These are the three authors of our book. So simply one after another names can be put across. Similarly, a multi-set of keywords can be constructed as follows. Multi-set is computer, database, SQL. Keywords आता infinite keywords असतील पण त्यातले तीनच आपण consider करू आपल्या उदाहरणासाठी. Thus we can create a tuple of the type defined by books relation as compilers, bookचं नाव, array म्हणजे ऑथरचं नाव, स्मिथ अँड जोन्स, न्यू पब्लिशर मॅग्रो हिल, न्यूयॉर्क, मल्टीसेट कोणाचा? कीवर्ड्सचा, पार्सिंग अँड एनालिसिस. Here we have created a value for attribute publisher by invoking a constructor function for publisher with appropriate arguments. Note that this constructor for publisher must be created explicitly and it is not present there by default. It can be declared just like the constructor for name, which we have seen earlier. If we want to insert the preceding tuple into the relation books, then how it is done? Look at the following statement carefully. Insert into books. Which values are to be inserted? Compilers, books now. Array, author ची नावं. New publisher, नवीन publisher add करायचं, McGraw Hill, New York. And multi-set of parsing and analysis. Keywordचा multi-set. We can access or update the elements of an array by specifying array index. For example, author array. Now, second, how to query collection valued attributes. Collection value attributes, kadun, how to perform query operations. That is to be understood throughout this second slide. We now consider how to handle collection valued attributes in queries. An expression evaluating to collection can appear everywhere that a relation name may appear, such as in a from clause, as the following paragraph is illustrating. We use the table books. Books आपल्याला सोपं जातं example understand करायला. So we will understand the books relation that we have defined earlier. If you want to find all books that have a word database as one of their keywords, then we can use this query. Select title from books where database in unnest keyword set. Now the unnest keyword we have used and how and why it is used, that we will understand. Note that we have used unnest keyword set in a position where SQL without nested relations would have required select from where clause. If we know that particular book has 3 authors, we could write select author array 1, author array 2, author array of 3 from books where title is nothing but database system concepts. आपल्या पुस्तकाचं नाव, database system concepts. Now suppose that we want a relation containing pairs from title author name. For each book and each author of the book, we can use this query. Select b.title a.author from books as b, unnest b.author array as a of author. Since the author array attribute of books is a collection valued field, unnest b.author array can be used in a from clause where a relation is expected. Note that tuple variable b is visible to this expression since it is defined earlier in the from clause. When unnesting an array, the previous query loses information without the ordering of the elements in the array. The unnest with ordinality clause can be used to get this information as illustrated by the following query. This query can be used to generate author's relation, which we saw earlier from the books relation. Select a title, a.author, a.position from books as b, unnest b.author array with ordinality a, author and position. The with ordinality clause is responsible for generating an extra attribute which records the position of the statement in the array. Remember it will be used for MCQ. The with ordinality clause generates an extra attribute which records the position of the element in the array. A similar query but without a with ordinality clause can be used to generate a keyword relation. Now, शेवटचा यातला point, nesting and unnesting. The transformation of a nested relation into a form with fewer or no relation valued attributes is called unnesting. The transformation of nested relation into a form with fewer or no relation valued attributes is called as unnesting. The books relation has two attributes, author array and keyword set, that are collections, and two attributes, title and publisher, that are not. Suppose that we want to convert the relation into a single flat relation with no nested relations or structured types as attributes. We can use the following query to carry out the task. Now understand, here this title, author, publication name, publication branch and keyword. If you look at the table, it simply says it is the relation flat books, result of unnesting of attributes, author array, keyword set of relation books. And unnesting means disintegrating into parts. So the query is select title a.author, publisher.name as pub name, publisher.branch as pub branch, and k.keyword. From books as B, unnest, focus on this particular term, unnest b.author array as A of author, unnest b.keyword set as K of keyword. The variable B in the from clause is declared to range over the books. The variable A, however, is declared to range over the authors. B for books and A for ranging over authors. For the book B, and K is declared to range over the keywords in keyword set of book B. Now the next figure shows instance of book relation which we call flat books. That is the result of preceding query. Note that the relation flat books is in one NF form. This relation flat books is in first normal form, since all its attributes are atomic valued, because there is no divisibility. Every attribute is indivisible. So this is first normal form. So try to remember this. The reverse process of transforming one NF relation into nested relation is called as nesting. Nesting can be carried out by extension of grouping in SQL. In the normal use of grouping in SQL, temporary multi-set relation is created for each group and an aggregate function is applied for temporary relation to get a single value. The collect function returns the multi-set of values. So instead of creating a single value, we can create a nested relation. Suppose that we are given first normal from flat books, as in figure that we have seen earlier. The following query nests the relation on the attribute keyword. So how is this query? म्हणजे मागचा जो टेबल आहे मोठा फर्स्ट नॉर्मल फॉर्म मधला, तो आता फोर्थ नॉर्मल फॉर्म मध्ये आला. तो कसा आलाय बघा या स्लाइड वरचा. क्वेरी काय? सिलेक्ट टायटल, publisher pub name, pub branch as publisher, and we have to collect all the keywords as keyword set from flat books, and we have to group it by title, author and publisher. So result of the query is shown in the table at the bottom of the slide. If we want to nest the author attribute also into multi-set, we can simply use another query. So इथं author सुद्धा आपले ठीक आहे, ऑथरचं नेस्टिंग झालेलं नाहीये, ऑथर अननेस्टेड आहेत, त्यामुळे आपल्याला 4 टपल्स दिसत आहेत, बट ऑथरचं पण आपल्याला नेस्टिंग करता येईल. पब्लिशरचं मात्र टेस्टिंग झालंय, कीवर्डचं मात्र नेस्टिंग झालंय, ऑथरचं राहिलं होतं. ऑथरचं नेस्टिंग पण आपल्याला करता येईल. कलेक्ट ऑपरेशन वापरायचं. कलेक्ट ऑपरेशन, सिलेक्ट टायटल, collect author as author set, publisher pub name and pub branch as publisher. Also keywords are collected as keyword set from flat books. Flat books मध्ये मोठं रिलेशन हे फर्स्ट नॉर्मल फॉर्म वाला रिलेशन, आणि त्या फ्लॅट बुक्स मधून आपल्याला काय बनवायचं, ग्रुप बाय टायटल अँड पब्लिशर नेम. Another approach to creating nested relations is to use subqueries in the select clause. An advantage of the subquery approach is that order by clause can be used in the subquery to generate the results in the order desired for the creation of an array. The following query illustrates this approach. The keywords array and multiset specify that an array and multiset are to be created from the results of subqueries. Now here, let us understand the query. Select title, array, select author from authors as A, where A is a variable for ranging over author, B is a variable for ranging over books, where A dot title is equal to B dot title. Order by A dot position as author array, publisher on pub name and pub branch as publisher, multiset on select keyword from keywords as K, where K dot title is equal to B dot title as keyword set from books for as B. The system is executing a nested subqueries in the select clause for each tuple generated by from and where clauses of the outer query. Observe that attribute b dot title from the outer query is used in the nested queries to ensure that only correct set of authors and keywords are generated for each title. Now, SQL 2003 provides a variety of operators on multisets, including a function set m that returns duplicate free version of a multiset m. Duplicate free version नको पाहिजे असेल, duplicate free version पाहिजे असेल आपल्याला या सेट वरचा, then we have to go for that set m operation. Intersection aggregate operation is used, which returns intersection of all the multisets in the group. Fusion set intersection पुढचं operation fusion aggregate operation, which returns union of multisets in a group. And sub multiset predicate which checks if multiset is contained in another multiset. The SQL standard does not provide any way to update multiset attributes except by assigning new value. Example is, to delete a value v from multiset attribute A, we would have to set it to we would have to set it to A except all multiset values. Now, second last point of this particular chapter, query identity and reference types in SQL. Query identity and reference types in SQL. So very in a matter of 4 to 5 slides, this will be done, and we will try to end this particular chapter, fourth chapter. So object-oriented languages provide the ability to refer to objects. An attribute of a type can be of reference to an object of a specified type. For an example, in SQL, we can define type department with a field name and a field head that is a reference to the type person, and a table departments of type department as follows. Create a type department, name, then head is of reference, the scope is of type people, create table departments of type department. Here the reference is restricted to tuples of the table people. The restriction of the scope of reference to tuples of a table is mandatory in SQL, and it makes references behave like a foreign key. We can exclude the declaration scope people from the type declaration. Instead, we can make an addition to the create table statement. Create table departments of type department head with options scope people. The referenced table must have an attribute that scores the identifier of type tuple. We declare this attribute called as self-referential attribute by adding ref is clause to create the table statement. So the improvised or changed definition is create table people of person. Ref is person ID system generated. Here, person ID is an attribute name. It's not a keyword. And the create table statement specifies that identifier is generally automatically generated automatically by the database. Now, in order to initialize the reference attribute, we need to get the identifier of the tuple that is to be referenced. We can get the identifier value of a tuple by means of a query. Thus, to create a tuple with reference value, we may first create a tuple with null reference and then set the reference separately. So, the query can be written as insert into departments, values CS null, update departments, set head is equal to select p dot person id from people as p, where name of the person is equal to John, where the name of the department is equal to CS. Alternative alternative to system generated identifiers is to allow users to generate identifiers. Now, the type of self-referential attribute must be specified as part of the type definition of the reference table. And table definition must be specified that the reference is user generated. Create type person, such as having name and address, and ref using varchar, reference using varchar. Create table people of person, reference is self-referential, person ID user generated. Magachi आपण पाहिला system generated. Now we are into user generated. When inserting a tuple in people, we must then provide a value for identifier. Insert into people, person ID, name, address, values. So person ID, we can put any random number. The name is John and address is 23rd, anything. No other people for people is super tables or subtables can have same identifier. We can then use the identifier values when inserting a tuple into departments without the need of a separate query to retrieve the identifier. Insert into departments, values are department CS and the person ID 01285667, whatever the relevant number. It is even possible to use existing primary key values as the identifier by including ref from clause. Magashi ref is bagitla, a ref from clause. Create type person, name, primary key. Of course, name is given the primary key. Address, ref from name. Ref is चाइवजी आता है ref from येता है. Create table people of person. Ref is person ID that is derived. Note that table definition must specify that reference is derived and must still specify self-referential attribute name. It has to still specify self-referential attribute name so that ref is appearing over there. When inserting a tuple for departments, we can use insert into departments values such as CS and John. References are dereferenced in SQL 1999 by this particular symbol, by that arrow symbol, forward arrow symbol. Consider departments table defined earlier. We can use this query to find names and addresses of the heads of all departments. So dereferencing साठी हे वापरतात. Select head, name, head address from departments. An expression such as head name is called as path expression. This sort of expression is called as path expression. Since head is a reference to a tuple in the people table, the attribute name in preceding query is the name attribute of the tuple from the people table. References can be used to hide join operations. In the preceding example, without the references, the head field of department would be declared a foreign key of the table people. To find the name and address of the head of department, We would require an explicit join of the relation departments and people. The use of references simplifies the query considerably. We can use the operation deref. We can use operation deref to return the tuple pointed to by reference and then access its attributes as shown in below. Select deref head.name from departments. Now the final point of this particular chapter through which we will conclude our chapter, and this particular question will be there in exams, as our exams are going to be multiple choice questions based. So you may have a couple of questions on this particular bit, on this particular point. So we say object oriented versus object relational databases. So as we have understood object relational databases, which are object oriented databases built on top of a relational model, as well as object oriented databases which are built around persistent programming languages, and object relational mapping systems which build an object layer on top of traditional relation databases. Each of these approaches targets a different market. The declarative nature and limited power compared to programming languages of SQL provides a good protection of data from programming errors and makes high-level optimizations such as reducing I/O relatively easy. Object relational system excuse me object relational systems aim at making data modeling and querying easier by using complex data types. Typical applications include storage and querying of complex data, including multimedia data. A declarative language such as SQL, however, imposes significant performance penalty for certain kinds of applications that run primarily in main memory and that perform a large number of accesses to the databases. Persistent programming languages are targeting such applications that have high performance requirements. They provide low overhead access to persistent data and eliminate the need for data translation if data are to be manipulated by programming language. However, they are more susceptible to data corruption by programming errors, and they usually do not have a powerful querying capability. Typical applications are including computer-aided design databases. Now, object relational mapping systems allow programmers to build applications using object model while using traditional database system to store the data. Thus, they combine robustness of widely used relational database systems with the power of object models for writing applications. However, they suffer from overheads of data conversion between the object model and the relational model used to store the data. We can summarize the strengths of the various kinds of database systems in this way. Relational system की strength: simple data types, powerful query language, high protection. Persistent programming languages based object oriented databases याचे features किंवा strengths: complex data types, integration with programming language, and high performance. Object relational database systems: complex data types, powerful query languages, and high protection can be the strength of object relational systems. Object relational mapping systems are complex data types integrated with programming languages, designed as a layer of top of relational database systems. These descriptions hold in general, but keep in mind, we have to note that some database systems blur the boundaries. They can enter into each other's territories. For example, object-oriented database systems built around a persistent programming languages can be implemented on top of a relational or object relational database systems. Such systems may provide lower performance than object-oriented database systems built directly on storage system, but they are providing some of the stronger protection guarantees of relational systems. So with this, we conclude our chapter. We conclude our fourth chapter. Uh, I request all the people, all the present participants to appear for this quick quiz, chapter 4 quiz. I hope everybody is listening over here. Everybody is able to hear my voice. Okay, so it is 11:40. So next 10 minutes, you try to solve this particular quiz based on the discussion that we had during this, during this particular session. Attend this quiz. Try to attempt this quiz, and by 11:50 or 11:55, we will go for attendance. I hope thing is clear. Whoever is sleeping, please awake. Please get up. Try and solve the quiz. Only 10 questions are there, and these quizzes and these chapter tests will be utilized for your internal marks, external marks, for that purposes. So try and definitely attempt the quiz as per your own knowledge. If there are problems in attempting, then do let me know. I'm here for next 10 minutes. Only 10 questions are there. You are very much habituated for attempting the quizzes. Attempt the quiz, and by 11:50, 11:55, we will go for attendance. So I need all the people to attend this quiz, and attendance is mandatory, because unless and until you have that 80% attendance barrier, 80% attendance benchmark, you will not be allowed for university exam. So try to attend all the lecture here onwards. Try to make sure that all your friends are joining for the lectures. Unnecessarily entire semester will be detained if attendance becomes less than 80%. Every student must join. Every student must appear for this submission things. Attempt this particular quiz. Once again, I am putting the quiz link inside the chat box for your simplicity. Very simple questions are asked. Attempt the quiz. योगिता आठवले क्विज अटेम्प्ट करा. माईक नका चालू करू. All the students are requested to attempt the quiz. Link is shared. Google form link is shared in the chat box. हाँ मी स्लाइड शेअर करेन. डोंट वरी आय विल शेअर द स्लाइड्स. डोंट वरी. आणि महत्वाचं म्हणजे अटेम्प्ट करा क्विज, कारण काय ना ही प्रॅक्टिस होऊन जाईल. तुमची एक्झाम एमसीक्यू टाईपची असेल. सो माझा प्रयत्न आहे की प्रत्येक प्रत्येक लेक्चरच्या शेवटी एक 5-7 किंवा एक 10 क्वेश्चन तुम्हाला प्रॅक्टिससाठी द्यावे, है ना. तुमची जरा मानसिकता चांगली तयार होईल. या एमसीक्यू खूप साऱ्या एमसीक्यू ला अटेम्प्ट करायची. सो प्रत्येक लेक्चरच्या शेवटी जमलं तर ठीकच आहे, किंवा ऍटलिस्ट अल्टरनेट लेक्चर आठवड्यातनं एक तरी असं 10-10 क्वेश्चन 20-20 क्वेश्चनचा आपण अटेम्प्ट करूया. मी आता लगेचच मेल करतो. मेल केलाय प्रवीण, 4 चॅप्टरचा मेल केलाय. पीपीटीज मेलवर टाकलेले आहेत. सो एव्हरीबडी इज रिक्वेस्टेड टू टेक नोट ऑफ द सेम. थोडं कनेक्ट मध्ये राहा. आणि त्या बुकची पण पीडीएफ तुम्हाला देऊ का प्रवीण? Abhishek Kalse, Aishwarya Metkari, Amol Salunke. I hope you all are attempting this quiz. Harshal Ramgude, Pooja Sarvade, Prajakta Pore, ऋषिकेश मेत्रे, समीर देवळे. आजच्या आपल्या डिस्कशन वरचा सिंपल क्विज आहे, सिंपल क्विज. एक चॅप्टर टेस्ट म्हणून सुद्धा आणि तुमची प्रॅक्टिस व्हावी म्हणून सुद्धा. ना डायरेक्ट वर्ल्ड कपला उतरून उपयोग नाही. थोडी नेट प्रॅक्टिस आपली असायला हवी. डायरेक्ट युनिव्हर्सिटी एक्झामला एमसीक्यू ला उतरला तर तुम्हालाही प्रॉब्लेम होतील. आपण प्रॅक्टिस करत राहूया. ऍटलिस्ट वीकली एक दोन असे एमसीक्यूचे 10-20 एमसीक्यूचे टेस्ट सॉल्व्ह करायचा प्रयत्न करू. असं नाही की अगदी लगेच 24 तास त्याचा अभ्यास करा. आपल्या डिस्कशनवर डिपेंड आपली ती एमसीक्यू टेस्ट असेल तुमच्या प्रॅक्टिससाठी. दॅट्स इट. सो एक 2 मिनिटं अजून वेट करूयात. If some people are still remaining to attempt this particular test, Aishwarya Metkari, गुगल फॉर्म लिंक शेअर केली आहे, त्याच्यातून क्विज पटकेनी सॉल्व्ह करायचा आहे. All right, it's 11:52. Let's go for the attendance. I hope everybody's attempted this particular quiz. आणखीन एकदा मी लिंक टाकून ठेवतो, कुठेतरी वाटल्यास कॉपी करून ठेवा. प्लीज अटेम्प्ट करा. तुमची नेट प्रॅक्टिस चांगली व्हावी आणि इकडं आपल्याला इंटरनल मार्कांसाठी सुद्धा रेकॉर्ड सगळं बनवायचं आहे. सो क्विज अटेम्प्ट करा. गुगल फॉर्म वाला सिंपल 5-10 क्वेश्चन वाला क्विज आहे. क्विज अटेम्प्ट करा, नका आळशीपणा करूत. सो रोल नंबर 1 to 5. Roll number 1 to 5. Roll number 1 to 5. Whoever is present, please put your numbers across in the chat box. योगिता आठवले, लेट आले बरं का तुम्ही. मगाशी सेशन मध्ये पण लेट आलात, नका लेट करत जाऊ. रोल नंबर 1 to 5. ओके. 6 to 10. 6 ते 10. कम ऑन फास्ट. 6 to 10. ओके. 11:15. 11:15. I'm taking attendance and I'm requesting all the people to come quickly. 11 to 15. ममता जांगीत बऱ्याच दिवसांनी दिसत आहे. 16 to 20. 16 to 20. 16 ते 20. परत अटेंडन्स घेणार नाही. आत्ताच अटेंडन्स मध्ये तुमचे नंबर्स मेन्शन करा. 16 ते 20 झालं. 21 25 21 to 25, 21 ते 25. Whoever is present, you are requested to put your numbers across. Okay. 26 ते 30. ओके. 31 35. ओके. 36 ते 40. 36 40. 5 पैकी पटपट नंबर टाकायचे प्रेझेंट आहेत. 36 to 40. ओके. ओके. 41 ते 45. 41 to 45. फोर्टी वन टू 45. ओके. 46 50. 46 ते 50. एकावन्न ते 55. 56 ते 60. 56 ते 60. 61. 61 ते 65. 66 ते 70. 66 70. 66 70. 66 70. अटेंडन्स मेंटेन करा, नाहीतर डिटेन होताल अचानकपणे. आणि 66 70 झाल्यानंतर शेवटी 71 ते 75. ऋषिकेश मेत्रे कुठे गेला? हा. ओके. अभिषेक कळसे. कळसे मगाशी होते की कळसे. कळसेंना काय झालं? भाग्यश्री मुंडे टाइमवर का नाही येत बरं? हे नंतर सगळं परत कचरा मला साफ करत बसायला लागतो ना. अभिषेक कळसे कुठे गेले? मगाशी दिसत होते की स्क्रीन मध्ये. ओके. ठीक आहे. ऑल राईट. तुम्ही आता नोटीस वाचली असेलच. उद्या सुट्टी असेल तुमच्या ऑनलाईन लेक्चर्सला. उद्या ईद असल्यामुळे. तर उद्याची सुट्टी असेल. दुपारचं सेशन अटेंड करा. अटेंडन्स मेंटेन करा 80%. मग आपल्याला एक्झामसाठी प्रेफरेबल होईल सगळं. आणि अकॉर्डिंगली लेट्स होप फॉर द बेस्ट. लेट्स होप फॉर येस. कोमल कडलासकर टाइम मध्ये येत जा. त्या वेळेस येत जा. नंतर त्रास नका देत जाऊ मला. So it's all right. Let us meet some other time, probably on Saturday or Monday. Once again, I'll try to catch up with you. So till then, uh, keep a watch on WhatsApp group. If there are certain academic related things, do take a follow up. If there are campus related things, do take a follow up. And meanwhile, attempt our quizzes that I'm trying to put across. All right, so goodbye. You can leave. हाँ